So, the main point I want to make in this episode is that we need to change our idea of what it means to understand something. Science is not bad. Science as a process is wonderful. Look at the nature objectively. Try to understand things rationally, logically, make observations, come up with explanations and models. Okay, good. That's all good stuff, right? Now, historically, so if we think about what the word understand means, historically, science has largely equated understanding with answering questions like this. What are the parts? How does each part work? What are the causal mechanisms? Can I derive the behavior of the whole from the behavior of the individual pieces? And that has been massively successful, right? But it implicitly assumes that understanding the parts is sufficient for understanding the whole. And again, going to the example challenges and so many more that I've given you, many modern systems and problems suggest something different. You can know almost everything about the components and still fail to predict the system. Why? Because the important information is increasingly stored in interactions, constraints, organization, feedback, adaptation, emergence writ large, right? In fact, the idea that prediction is even the thing to go after is highly suspect. Traditionally, it made sense, but for complex adaptive systems, which is where today's problems are sitting, it's much too narrow, right? So, okay, what can the word understanding mean? Understanding can mean prediction, right? Can I accurately forecast the future state? This is kind of the physics gold standard. It can also mean control. Can I reliably steer the system? In fact, medicine often cares more about this than perfect prediction, right? Because we don't obviously fully predict the body, but we can often move it toward a healthier state, right? Again, with a lot of side effects. Explanation can be a type of understanding. Can I explain why the behavior occurs? I'm not trying to predict it, not necessarily trying to control it, but can I explain it? And this is where reductionism has traditionally excelled, but under complexity, reductionist explanations just fall dead at the doorstep. And then there's navigation, and this is the one I think is the critical type of understanding we need in the age of complexity, because, well, what is it? What do I mean by navigation? Think about it like these types of questions. Where the stable equilibria are? What kinds of interventions destabilize it? Which variables matter the most? What feedback loops exist? Which directions are safe versus dangerous? That's a different type of understanding. It's almost like understanding a landscape instead of a trajectory. So let's go back to those examples and see what they would look like under this new type of understanding that I'm promoting here.